Hi there, welcome to another update on the progress I'm making on the Spectrum game development tool. Made a lot of changes around things relating to rooms and the game map this time round. A lot of under the hood stuff that you won't see, but hopefully this demonstration will give you a clear idea of the direction it's heading in terms of authoring larger maps and rooms and how things work in that respect. So the first thing that's changed, you'll notice, is the rooms editor itself is slightly different. I'm erring towards removing the tile editor altogether because it just seems unnecessary. It's an 8x8 grid, way too big to draw anything meaningful, and it can actually happen in here a lot better. So you'll see when I load up the sample game in a minute that it's much more efficient in here. It has some other advantages as well, which I'll illustrate. The map editor is the same as before, and there's some new nodes and things to facilitate the movement between rooms in the map. So let's start quickly by loading up the sample game. So I've got some data to work with. So now you come into here, you can see the advantages of having the tile editor within here. Is if you go into the room, you can actually see what the tile editor looks like, but you can actually go in and edit some of the tiles. So I've got this tile here is used in the brickwork. If I make changes to it, you can see it's actually changing live, and you can actually see much more efficiently what changes to the tile, what effect changes to the tiles have on the look of the room itself. A couple of other things on the ability to move between rooms. You'll see you've got a couple of objects here that appear to be outside of the main room area, and these are used for collision detection. There's basic collision detection implemented in the harness now. It's very simplistic at this point. It's just using the bounding box, so it'll be the bounding box 16 by 16 bounding box of the objects against other objects. Hence why it's off screen here, so that as you move this player, he'll only collide with it when he's gone off screen, which makes much more sense. So you can now see which object you've got selected by the green highlight. So if I select this one here, it's outside this door, you'll see I've got a variable on that object, which I'll show you in a moment, called room, which allows me to define which room the code will take the player to if you collide with that object. And I'll follow through the logic changes in a moment. Similarly, the other one, this one down here, will take you to room 2. So if we look at the map quickly, we can now see that you've got these room numbers on here, so this helps you to identify. I should probably change the way that you specify the room later, but for now it's just that index in this map. So again, this one will take you to 2, so if we go back to here, look at that one, we can see that it takes you to number 2. There's also, if we go to the second room, there's this object here, which is that one, and that will take you back to room 0. So we can get back, the theory is we can get back. Now looking at the objects, we've got the player. There's some changes in the logic, as I say, that allow this. I've modified the player code a little bit to use all the left, down, up, right inputs, and they just go through some simple math nodes. I won't go into the detail here of what they do, but they're just basically choosing a direction based on which buttons are pressed, and then moving the local variables xd and xy. The changes that are most significant here is around the move object. So before, this was simply just a move object, and it just had the flow go through onto the next node. Now we've introduced this. I've introduced this collision concept here. So when you do a move object, it will, if this flow is connected, it will check to see whether the resultant move causes a collision between it and other objects. Only objects at the moment, not the map, but that's coming. So if you follow through on here, anything that goes down here will result only if there has been it will be executed only if there has been a collision, and you can follow this one off through if there is no collision. The other thing that's created here is if there is a collision within the execution of this node, this output port will change to identify the object that you were collided with. So this is a new color. So we had white, green, now we've got blue. Blue is an object reference which can be used in other nodes. This is the only node that uses it at the moment. So this new node here is an object variable which allows you to get the variable value from another object via one of these references. So it's very similar to where are we? Get variable, which gets the variable on the current object, the player that we're working with, but this allows you to get variable values based on other objects or that are referenced on other objects. So it has some strange behaviour that may be a little bit weird at first, but I'll try and explain why. So you take in the reference here, and you have to define the object type that you're expecting to get here, because the only way in terms of the actual generated code, it's important that the system knows what type of object it's looking at, otherwise it can't query the data correctly. And I'll show you the code in a moment, see what that looks like. And then there's a variable name. Again, this will probably change because now we have information about which object type. I can list the variables on that object, but for now it's just a name. And then you've got two flows out of here, valid or invalid. So valid will execute if the object that's referenced here is of type enemy1. So it's as well as getting the variable, it's actually checking to see that the object is correct type all in one node. If it's invalid, which means this object is not of type enemy1, then it will flow through that one instead. So if we've got a valid flow, the code flows through into the next node, and this value is set here to the value of that variable on that object. So if you remember back here, we had on our enemy, if we go to this one here, we had a variable on this object room. So it's basically getting the room number to go to based on which instance of the enemy object you've collided with, and then doing a change room. So this change room is exactly the same as before. You can choose the room specifically, or you can put a room number in from another node. So that's basically what it's doing. It'll move the object. If it collides with something, it'll run this code which checks to see if the something is an enemy one, and if it is, it will get the room number and change room. So that's basically that. I think that's all that matters there. There's a couple of other things changed here. One thing is this introduction of this new button up in the toolbar. This is just for convenience really, so it does instead of doing a full export, it's more for me than anything really, but I suspect others will find it useful. It does a dump of the code that will be generated and just shows you it before you start. So things that have changed since the last time, you can see down here we've got the game rooms, which represents the map. So there's 3 rooms, 0, 1 and 2, and that's just the map. And if we look up to the player code, there's a lot in here now. So this is the player logic for always, which is this here that we can see here. So this is doing all of the key input, direction checks stuff to see which key's been pushed. It's QAO and P, which are standard spectrum keys, and then it's moving the object to that new position. And because we have the collide flow, it does a collision check, which is a new function in the harness. And if it has collided with something, it will go through and do the code here, which is to get the variable number, the room number, and call through to the room changed, or actually set the room changed, which the harness will then pick up and do a change on the room. So if I export that properly now, and then go to our, I can copy that across and recompile. It's taking a little bit longer to compile now. We've still got full optimization, so it takes a moment to compile. And if everything goes according to plan, we should now be able to go to the emulator, load that up, and you can see, so we've got full movement now, QAO and P. And if I walk off the bottom here, it should take me into the other room, and I should be able to go back. And similarly, if I go off this one here, it takes me into the bottom of the other room. There's some strange behaviour here with the sprites. I'm not entirely sure what it is. It seems to be corrupting under certain conditions. It seems to be when I change rooms. I need to look into that. I'm not overly concerned at the moment. So that's basically how it works. That's how it'll look. This is a bit of a contrived case. You wouldn't normally, I don't suspect, have this weird configuration. There'd probably be more likely a grid, but it does show that you have that flexibility to do that, and it works out where the player should be correctly within the room based on the room position on the map. So global objects retain their position relative to the room. I think that's it for now. I'll come back with some more as and when. Thanks for watching. Please don't forget to subscribe if you want to see more of this as development progresses. I'll try and post videos maybe every week or so, depending on how much time I get to progress. Hope to see you again soon.